sine of theta plus 2 pi. All of a sudden, you go into a calc class and say sine of theta plus 2 pi. And I know every student in this classroom, when I show you what it is, you'll say, oh my goodness, that's all it is. Does anyone have an idea? Sine of theta plus 2 pi, got your little thinking. And it's not distributive property. It's not sine theta plus sine 2 pi. Can't do it that way. Got to think about what it means. There we go.
Zero?
Not zero. Either way, it says zero. Not zero. Because I think I'm thinking about sine of 2 pi, and sine of 2 pi is zero. Okay. Here's what we got to do. Thinking in math, not necessarily trying to solve something. No distributive property, many students try to distribute sine on those two. You can't do that. Guys, theta plus 2 pi translates into, without doing much work here, you have an angle, and then you move 2 pi more from there. Where's that going to take you? If I give you an angle of some size, and I say now move 360 degrees from there, move 2 pi, which is the period for sine. What does that tell you? For example, I give you a 30-degree angle. I say now move 360 degrees, which is the period. From there, where are you going to land?
Same spot.
Same spot. Aren't you? If I gave you an angle and I say move 360 degrees, isn't that going to take you right back to where you started? So sine of theta plus 2 pi, look at this, guys. It's equivalent to this. Just sine theta. It's going to take you right back. Now, does that work for, let's do this one, cosine theta plus 2 pi. Same type of thinking, guys. No math involved here, just thinking. You have an angle, you move 360 degrees or 2 pi from it. Does that take you right back to whatever angle I give you, takes you right back to where you started? So this is equivalent to just cosine of where you started, theta. Now this one, look at this. Tangent says theta plus pi. Anyone tell me why they changed it to pi? What's the period number that makes things repeat? For pi, what was the period for the parent tan graph when I did the parent tan graph? Was it pi? So this one has pi though. We'll take you right back. H5 tan theta. The guys, sine, cosine, tan, those are the three basic ones. You could also do this with the secant, cosecant, cotangent, and it just takes you right back. So one of them has 2 pi period, tan has pi, cotan has pi, secant, cosecant has 2 pi. I thought I'd mention that, just in case you ever see it. It does just take you right back. Now, this is where I want to go now. You guys at 4 o'clock, you were with me. I brought this in, and I don't think it's the same problem we saw at 4 o'clock. I'd like to look at this function, 2 cosecant 2x minus pi, subtract 4. I don't think it's the same one, is it, guys? Is that the same one or not? No? Okay, so I'll change it a bit here. Now, we're hoping for the best. I'd like to sketch it. That's what I want to do. I myself, guys, I don't want to go through all those transformations. I'd like to go through this process called bounding if we could. That means I need to go to my argument, clean it up, take out that common factor of 2, or take out 2, and rewrite the inside part like that. Now, if on the exam next Wednesday, you get one of these, and you do it by transformations, and some students may not mind transformations, I'll give you credit for the final graph. But look at this, that would take you some time here. What, a vertical stretch by what, 2? Horizontal strength by 1/2? A horizontal shift to the right, what, pi over 2? A vertical shift down 4? You're gonna be there forever, but definitely if you do it like that and you get to the final graph, I'm happy. Is that true? Yes?
When there's no negative in front of the x, is it necessary to take the 2 out, or could you just do the inequality 0 is?
Hold on. Oh, you bet right here?
Yeah.
Beautiful, that's the best case. If there's not a number there. You said it perfectly, then you just jump right into bounding.
Oh, so if there's a number there, you have to.
You have
take
to.
it out. Okay.
Yeah. For a reason, for a reason. Oh, I see exactly what you're thinking. Exactly. We're gonna just do it for a reason. Guys, agreed so far? Okay. Now, with this bounding technique, you guys don't make it hard on yourselves, just a little technique. That means I'm gonna bound this so-called argument. I'm gonna leave mine in this form. This is exactly what she was talking about right there. I'm doing cosecant. Just want to recall what cosecant's bounds were to get the full graph of a cosecant function. I think it was from 0 to 2 pi that we used. We're going to bound this one the same way. Here it goes. I had to show you this, even though it's going to take a little time. Bound it from 0 to 2 pi. Now solve for x, and I've got to be careful myself, guys. Divide everything by a 2, you end up with 0. Less than x subtract pi over 2, less than pi. Let's divide everything by 2 there in that inequality. Add pi over 2, and I'm going to bring it here so you guys can see it. Now add pi over 2 to get the x completely by itself, and you're going to end up with pi over 2 less than x less than, and when I reach this end, pi plus pi over 2, put them together with a common denominator of 2, I think you end up with 3 pi over 2. Do we agree with that? Yes or no? That is quick. I see the heads nod, yes? Are we okay? Now, if all that's correct, I haven't done the graph yet. Are we okay so far? We're going to make any mistakes here. If I'm correct, the period of the graph can now be discovered real quickly. There's so much math up here. Take the ending of the cycle, which we think is there, there's no mistake. Subtract the beginning. Guys, you know that's going to be 2 pi over 2. So you're going to say this graph, when I finally get it, has a period of pi. Which you may have been by a formula. Some of you guys do it by formulas to find the period. I think you find the same thing, pi. Yes or no? Now I need my spacing number. There you go. And find the spacing. We're going to divide by 4. So let's take pi over 4. That would be nice. That represents when I finally get to the grid, how much spacing I'll do. All that's involved. So far, so good? Okay. Now, I did not on this one have to worry about even or odd. Even or odd would be if there were a negative sign inside here. You may want to consider even or odd to help yourself out. Guys, let's see what this one looks like. On the grid here. And I thought about markers in the better. Okay, geez. My graph is supposed to start at pi over 2, we think. Much better. And end at 3 pi over 2. Put it out here. With a spacing of pi over 4. So I see a 4, I see a 2. So let's come up with a common denominator. Guys, we'll use 4 here, so let's call this 2 pi over 4 if you don't mind. Just renaming. Let's call this one 6 pi over 4 if you don't mind. And I'm spacing by pi over 4. So we have 3 pi over 4, 4 pi over 4, squeezing this in, and a 5 pi over 4. Is that true? Here we go. That's done. I would suggest after you do that, guys, you need not worry about this part anymore. After you do the bounding, that's done. All you need to worry about is that vertical stretch by a factor of 2 and a vertical shift down 4. Okay? And then remember what the parent cosecant graph looked like to begin with. You guys, here goes. Can anyone tell me at the very beginning, based on what the parent cosecant graph was doing at its beginning, what might be happening at the very beginning? I've got it here. asymptote here, guys. He's telling me, Virgil, he's the professor, when I look back at the parent graph, that's the way the parent started. And if there's an asymptote there, I think there's gonna be one also here. And I think there's gonna be one at the end. You guys agree? Okay. Now, what I have the asymptotes out of the way with his help. Now I need to consider my graph has a vertical shift down 4. So I'm going to do this. I'm going to drop down 4 and show that my x-axis is now down here. That's my new x-axis. That's where everything's going to take place down there. And then also, can't forget, it's being stretched by 2. So by the way, since we'll be stretched by 2 above and below, let me get ready for it. Looks like a -2 is going to bring it apart up and stretch down. Looks like a -6. Place that there, just to get ready for it. Is that true, guys? -2 and a -6, stretched by 2. Now the graph itself. Thank goodness, it's not upside down, is it? Nope. So it should behave much like the parent did. I got the asymptotes in place. I gotta be careful. I've got a stretch by 2. Does that mean, guys, help me out here? Does that mean it's going to pick up this point and help me out? Should use a different color. And one branch opening up may do something like this, or not. And the other one is going to be on the other side, down at -6, if we got it correct here. And looks like it, with the asymptotes, will do something like this. It's going to open down. See if you guys will agree. Might the other piece be down there. And there's your sign. Well marked. Everything that you need to look at there. How's that look? Okay. Now the domain on this graph, here's where I suggested 2 by 4 o'clock session. Guys, the domain on these with the asymptotes sometimes is difficult to come up with. X cannot be, and just standing here I know, X cannot be 2 pi over 4, 4 pi over 4, 6 pi over 4, so there is a pattern there. If I can come up with that pattern in my mind and write out a little formula, they want a formula for the domain. I would suggest this. Take the first one, which is 2 pi over 4, or pi over 2 if you wish, and say, hold on, professor, there's also an asymptote from 2 pi over 4 to the next one, 4 pi over 4, this the distance is what? 2 pi over 4, and from here to here, another 2 pi over 4, so you can say, okay, add to it 2 pi over 4, I'll reduce all this down in a second. Any number of times you wish, where n is an element of the integers. Let me make it look better, reduce down. This is pi over 2, of course. And this is also looks like a pi over 2, any number of times, where n is an element of the integers. Wow. Does that look good? So that should tell me the locations of all the asymptotes. I hope. Okay. By the way, I got 6 pi over 4 on the end there as an asymptote. Let me start. If I replace n by 0, I do it pi over 2. Yeah, pi over 2. If I replace n by 1, we'll check here. N by 1, this becomes pi over 2 plus pi over 2. Guys, what is that? If I replace n by 1, do we have the formula wrong or what? 4 pi over 4, which is pi, and we get pi again. If I put a 2 in there, of course the 2's would cancel, you got pi over 2 plus pi, would that give me the 3 pi over 2, where I have 6 pi over 4? It would give me the asymptotes. That's what I'm looking for. And there could be some asymptotes on the left-hand side too. I have one cycle, I just want one cycle. That's where the graph looks. Looks cute. There's my domain. Range. Next Wednesday, the up and down is negative infinity up to a -6, looks like. Union then jumps from a -2 to infinity. Is that true? Okay, domain, range, period, there is no amplitude on this graph. I think we have everything we need, and I thought I'd point out like that, just to get ready. Okay, now, I can't do it today. I may just set it up for you. The 4 o'clock session solved, since they asked about something like this, I will be asking next week, please, tell me, please name for me the x-intercepts there on that graph. Should I go ahead and find at least one since I'm here? Okay, the x-intercept. And how to find the x-intercept? You always set your function. I'll do some erasing here, guys. 2 cosecant. Help me out here. Inside there was, I think it was this. I think it was 2. Guys, was it 2x minus pi to begin with? Help me out. Is that the original?
Yeah.
Okay, and then on the end was a minus 4? Okay, that's the original. That's what you would set equal to 0. And you got solid. I would suggest you divide both sides by 2. And makes this look like this. This is high level math going on here. Right, when you move that 4 over, guys, and divide it by 2, better, it's gonna be a 2 over there. Is that true? Move the 4 over, and then divide both sides by 2. Whew, don't make me mess up now. Cosecant sometimes is difficult to work with in an equation. Cosecant is related to sine. Sine is a little bit easier. What's the relationship between sine and cosecant? Shame on you.
1 over sine.
Yeah, they're reciprocals. So if you want to change this to a sine, which might be easier, you could say, Professor, can I rewrite it like this and still come up with the answers? You can. Just make this 1/2. Those 2 statements are saying the same thing. That's a relationship. I prefer the agreement. I prefer to work with sine than cosecant. So guys, to find what I'm looking for, hopefully, more races. If that relationship between cosecant and sine, I'm going to use sine. Now here's what you got to do. I got to be careful when I construct the test. I got to make sure I give you something that you can locate on the unit circle. Nothing crazy. Can anyone tell me where have you seen sine equal to a 1/2? On the unit circle. It's a positive 1/2. That's with a y coordinate. Which quadrants am I in, first of all, where y is positive? 1 or 2. Just consider 1 first. Does anyone know what this right here, sine is equal to 1/2? What angle in quadrant 1 has that y coordinate equal to 1/2? Pi over 6. 30 degrees. So that means this, to finish it up, this is representing, to make this work, 2x subtract pi is equivalent to pi over 6, because that's when sine becomes 1/2. I'm going to finish this up, solve it. For x, move that pi over, use a common denominator 6, and guys, we'll end up 7 pi over 6, to cut my work down a little bit there. I think, divide by 2 or take 1/2, and it looks like we end up with 7 pi over 12. Did I do that correctly? So I might think this one right here might be 7 pi over 12. It might be an x-intercept. Now, I notice on my graph here, 2 pi over 4, let's put this in terms of 12. This is what, 6 pi over 12? And this is 9 pi over 12. 6 pi, 9 pi. Does it make sense that maybe 7 falls in between? Right? For an x-intercept. And the other x-intercept you could find, if you wish, someone tell me, go through the same process, what could you now do to find the other one if you wish to find it? Okay, here we go, I'll find it for you.
Add it to 3 pi over 4.
But so, no, you may be able to do that. Something else though. Where on the unit circle have you seen besides pi over 6 is in quadrant 2, sine the y being equal to a 1/2? What size of the angle in quadrant 2 is that happen? We've got 5 or 6 out of the way. There's another one in quadrant 2, whose y coordinate is 1/2. Shame on you.
5, 5, or 6.
How much?
5, 5, or 6.
Gotcha. Gotcha. Let me try to finish this one up, guys. It is 5, 5, or 6. That's another possibility for 1/2 for the y coordinate sign. I move that pi over, 6, 5, or 6 plus 5 or 6. It's 11, 5, or 6, I think. Do the math there. Divide by 2 or take 1/2. The other one may be 11 pi over 12. It may be that one. 11 pi over 12. Let's see if it's located where it should be. In terms of 12, this is what, 9 pi over 12? And this one's what, 16 pi over 12? Wait, 9 pi over 12. Is this 12 pi over 12? It is, 12 pi over 12? 9 pi over 12? And I got what, 11 pi over 12? When 11 pi over 12 fall between? Those are my x-intercepts. And you got the graph, you got the domain, you got the range, you got the period. And that right there would be one big knockout problem on the exam next Wednesday. That would be a good 15 point, maybe a little bit higher, maybe 18 points to show me all this. Guys, I'm leaving it. I see more things I could have asked, but I'm leaving it. Okay, now part 2. Michael, you're gonna help me out here. I think now there's a section called this. Inverse trig functions. Now we'll keep this brief as I can, guys. Inverse trig functions, you say, oh no, Professor, you're going back to chapter 4, and you're going to say, we got to consider that again? F superscript -1, except now you're going on a trig function. So we're taking a look at, right now, something that looks like this. Inverse sine, inverse cosine, and then we'll consider inverse tan. They want to know how to come up with the inverse of the trig functions. And as fast as this stuff is moving, you're saying, Professor, I'm just now getting accustomed to the regular trig functions. I barely know sine, Professor. And you're going to ask me to flip it around on the inverse? That's what they're asking me to do in chapter 6. Guys, the inverse secant, inverse cosecant, inverse cotangent, they're there, they exist. Now we'll just consider these 3 main ones. Now, I'm going to do it this way. And move into it. I'm going to sketch the graph of the basic sine function. I'll make a connection here. If you guys are not at the top of your calc class when you take calculus, I'm going to find you. After all this, you should be scoring at the top of your math 7 class. Okay, I want the basic sine graph. Starts where? Starts at 0 for sine. Then it jumped up to 1. Goes back to 0. It drops down to -1, down here. Then back to 0. Just the sine wave. That looks something like that. Okay, that's just a basic sine graph. They want you to now find the inverse of this. And the trouble is, and I think I mentioned this on Monday, the trouble is that function is not 1-to-1. We're not passing the horizontal line test, therefore I can say there is none. And all of a sudden you check the keyboard of a calculator, go online and look, and they say, yes, it does exist. So how can it exist if this is not 1-to-1? Well, here goes. They modify, and when I say they, guys, the committee got together and did this. They took this sine graph and said, hold on, let's make it 1-to-1. And what they did this, I'm gonna erase this, guys. they went over on the other side at negative pi over 2 for a reason, and they're saying that negative pi over 2 sine is down there. They're going to chop off a piece of the graph. So I'm going to do this. Okay. Now please tell me, did we retain the 1 and the negative 1 that was previously on the sine graph? Is the positive 1, negative 1 still there? They kept that, thank goodness. It's just a little slither of the full graph. Would this piece pass the horizontal line test? Therefore, it now is 1 to 1. Now, the committee did this, not me, not part. Therefore, we're going to accept this. Now, if I say, now what's the domain on this little slither of this graph? Guys, the domain here would be, looks like negative pi over 2 up to a positive pi over 2 for the domain. The range of this little piece, up and down, negative 1 up to 1. Now here's where we get into the details. Now can someone look at this and tell me, if we accept this and made it 1 to 1. Can anyone tell me what do you think the domain on the inverse sine, and the range on the inverse, what do you think those would be? Can someone tell me what the domain of the inverse would be? They should be the same as what? The range of the original. What's this? The range of the inverse should correspond with the domain of the original, which we said was this, if we modified it. Okay. Now on the side here, Michael, I don't know how much I did on that handout. Let me check and see how much I did in my notes here. Okay, Michael, check on the handout. Did we start with like an inverse sine 1/2? To find some values here. Okay, we'll go to part C, guys. Here we go. There we go. Inverse sine 1/2. Let me ask this class, what do you think? Not sine 1/2, inverse sine 1/2. What do you think that's asking you to find? Keep in mind, everything's been flipped around. That's what an inverse does. It changes. What do you think inverse sine 1/2, not sine 1/2, inverse sine 1/2? Wonder what that's asking you as a student to answer. There we go. Okay, can you tell me what the y coordinate is here? Where is sine, or at what angle on the unit circle have you seen the y coordinate equal to 1/2? That's what they're asking you to find. They're not asking you to find sine of, this is inverse sine, backwards. So guys, on the unit circle, please tell me, I just heard interchanging coordinates. For inverse sine, let me do this. Would you agree on the unit circle, was that a point on the unit circle? Pi over 6 and 1/2. Was that a point on that unit circle? It's right on your unit circle. If you flip it around, interchange it, you're going to have now this. So what are they asking you to do you think, for an answer? What's the answer? They're going to say, now, inverse sine 1/2. What do we do when we flip it around backwards? The answer must be what? They're asking you to find the angle. At what angle on that unit circle have you seen the y coordinate be equal to 1/2? Is it pi over 6? Now, can someone tell me, and you should know this unit circle by now, where else on that unit circle, though, I better bring this in, where else have you seen, I'll put a comma here, where else have you seen the y coordinate equal to a 1/2 besides pi over 6? 5 pi over 6 on that unit circle. You check out 5 pi over 6 on the unit circle, you'll find that the y coordinate is 1/2 again. So, wait, Professor, there's 2 answers. Can't be 2 answers. It's supposed to be 1 to 1. So one of those answers has to be ruled out. That's what this value says. Now look at this, guys. The domain on my inverse sign, I did the sign here. The domain, and this right here is the domain, has to be caught between -1 and a +1. Did I use a number like 1/2? Is that caught between -1 and +1? So I satisfied that. The answer, look at this, which is a range. The answer they want must fall by restriction between -90 and a +90. Please tell me, this is 150. If you think in terms of degrees. Is 150, would 150 fall between these two by restriction? No. Would 30, in terms of degrees, would 30 degrees fall between -90 and a +90 if you line them up? So the one they want is the one that fits the restriction. So they want that. Nice. Okay, we'll do another one here. Inverse sine 1. I placed a 1 inside. Domain says you may place a 1 inside your which. This is your domain. Now, does anyone realize on the unit circle where have you seen the y coordinate sign equal to a 1? I hear pi over 2. Now, can I accept it? Well, we'll find out pretty shortly. You can't accept it unless you meet this condition. Now you're going to say put a bracket on pi over 2. This is included, and therefore you get the answer there. Done. Number 3. Inverse sine. Now, I need a clever response here. -1/2. You get an idea what this inverse does for you. Inverse sine -1/2. Anyone tell me, based on the unit circle, where have you seen, what angle, have you seen the y coordinate equal to a -1/2?
7 pi over 6.
Love it. And I think there's another one.
11 pi over 6.
Love it. Oh, very good. Mathematician, look at this now. I agree with them 100%. 100%. But watch carefully. I'm gonna do this in degrees. That's a little bit easier. This is 210 degrees. You convert it. This one's 330. Got 210, looks like a 210 and a 330. Let me check out 210 first. Would 210 fall between, by restriction, a -90 and a +90? No. That one is even worse. That's 330. Could you fit 330, positive 330, in between a -90 and a +90 if you line them up? No, it's outside. It's a professor, there's no answer. There's an answer. Do this on a calculator, you'll see an answer pop up on the screen. Does anyone have an idea? But this just started with you guys on inverses. What might you do to get an answer? This little process is not going to be what I want on this particular problem here. I'm going to give you an idea. Look at that 11 pi over 6. 330 degrees, guys. It's over here that he gave me. In quadrant 4, this is 11 pi over 6. Let's put a comma here. 330 degrees. And it's so large, it definitely will not fall between here by restrictions. I can't use it. But guess what we do? Does anyone know what we might do and watch what happens? We're going to make an answer come out. Yeah, I did. Yes.
Divide by 330 by 360.
Nope. Nope. So easier than that, which you may overlook.
Negative pi over 6.
Whoa, Mr. Mathematician, he's a professor. If you move backwards, they call it clockwise, would you end up the same place? And by the way, if I am moving backwards, I got 330 degrees. If I move backwards, I'm gonna call this negative, so I move backwards, 30 degrees. Are we talking about the same one? I'm gonna do it in radians now, it's pi over 6. So I'm gonna say, hold on, Professor, there is an answer, it's negative pi over 6. We finally got an answer to work out for me. Okay, guys, number 4, just point out a few things here. Michael, help me out here. Did I have some of these on the handout? I've had a mixture of inverse sine, inverse cosine, inverse tangent, I probably had them scattered about. Did I?
Yeah, sign will have it.
Okay, we got the 1/2 out of the way. Okay, we're trying another one here. Guys, this one. Inverse sine, negative square root 2 over 2. First, I gotta be careful. Inside there, that's my domain, and better fall between these two numbers, I can't do it. So if you approximate radical 2 over 2, the 1.414 divided by 2, it will fit. It's called between negative 1 and positive 1. So there should be an answer. Can anyone tell me, where have you seen on the unit circle, now I gotta be careful on this one, where have you seen the y coordinate psi equal to a negative radical 2 over 2? I wish I'd brought a copy of the unit circle in here again.
4 pi over 3.
Do it again.
4 pi by
4 pi over 3? I'll find you at.
What is it, 5 pi over 4?
Okay, 5 pi, it's gotta be something with pi over 4, 45 degrees. Was 45 degrees, pi over 4 was radical 2 over 2, radical 2 over 2. It has something to do with pi over 4. Brianna, you said 5 pi over 4. Hang on. And I will tell you that's down in quadrant 3, where sign should be negative. And there's another one.
7 pi over 4.
There you go. 7 pi over 4, that's in quadrant 4, and sine, the y coordinate, is negative. Those two work, but I can't accept them. I'm doing it in degrees. Guys, this is 225 degrees she gave you. It works on a unit circle, but by restriction, my answer's gonna fall between negative 90 and a positive 90. No way is 225 one fit. Out. 7 pi over 4, it works. On the unit circle, it's 315 degrees. No way is it gonna fit here. Can't use it. And you say, Professor, can I still get an answer? Anyone give me an idea? There you go. That's 7 pi over 4, 315 degrees, beautiful. Is here in quadrant 4. Guys, we'll do it in degrees this time. This is 315, 7 pi over 4. And if you move backwards, clockwise, 45 degrees. We're talking about the same angle. And then Michael says, go ahead and call it negative, Professor, pi over 4. And there's the answer. All these calculators have been programmed with this. Can you imagine if you press that key on the calculator somewhere and all of a sudden it shows 2 answers pop up on the screen? That's not going to happen. It's been programmed to give you 1 answer. Yeah.
On our handout for section 1 where we're doing equation that says tan 10 degrees times cotangent 170.
Oh, you want that one?
Would you be able to write that cotangent of 170 as 1 over negative tangent 10?
Whoa, 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 whoa. Yes. Yes, I'm gonna point that out. Thank you. Yes. Did you sort of get that insight with what we're doing right here?
Yeah.
Yeah, that's exactly right. I'm gonna point that out before we stop it, guys. Now this is inverse sine. I'm throwing in one more. I want to keep this as brief as I can. I give you 5 examples here for inverse sine. I can't give you 5 for inverse cosine, but I'm pointing it out. Inverse tan. I'm gonna try one more here, guys. Inverse sine 3. Now keep in mind your restrictions. You don't, right here's a little slither of the parent sine graph. That's what's making this come out. We made it 1 to 1. So we've got restrictions here. Inverse sine 3. Answer? There's no answer. Finally got one where there is no answer. Can anyone tell me why? Here's your domain. What's the domain supposed to be? It's supposed to be caught between -1 and +1. You can't use the 3 in there. It's got to be caught between -1 and +1. You're done. Wow, wow, wow. And I could I'll go on all day about this. Now, with that said though, part B, let me get this out of the way, guys. Now I'd like to consider this one. Inverse cosine. X. Inverse notation. Now let me remind you what the regular cosine graph looked like. I'll try to be as brief as I can on this one. The parent cosine graph looked like this. 0, pi over 2, pi, 3 pi over 2, 2 pi, went up to 1, dropped down to a -1, and I think at 0, guys, help me out, the cosine graph start at 1, then drop down to a 0, down to a -1, basic parent graph, back up to 1, and this is a cycle of cosine. Is that true? Okay. Would that graph, if I leave it just like it is, would that graph pass the horizontal line test? No. So it's not 1-to-1. So how on earth, if it's not 1-to-1, which is the main condition on inverses, how on earth can they ask me to find an inverse? They do the same thing they did on the sine. They chop a piece off. And then make it 1-to-1. Now, they have, the committee, I can call it committee, not part, not me, not SMC. Look at this. They're saying, please consider for cosine, that little sliver. Pi had a different sliver, this one has just that little sliver. By the way, would this now pass the horizontal line test if I should use a horizontal line test? Who on earth? I wouldn't think of it as a math person. I would think, what are you doing? Some mathematicians got together to do this, so things will work out nicely for us. Okay, that's the slither. If it is the slither, guys, the domain on this, on the slither itself, is 0 out to pi on the x. The range is -1 up to 1, again, on that little piece of that graph. Now tell me, please, I'm put in red, the domain of the inverse, right like this. Inverse cosine should be the same as the range was on the other piece. The range on the inverse, that should be the same as the domain on the original, which was 0 to pi. Now you have near restrictions to remember. Now on the side here, I'm not going to try as many as I did with sine here, guys. So that means that I actually find this, inverse cosine. Here we go, guys. Radical 2 over 2. Translated, wherever you've seen on that unit circle, the x coordinate equal to a radical 2 over 2. Anyway.
Pi over 4.
Pi over 4. Now, I think, put a little comma here for right now, I think there's another spot on the unit circle where the cosine is positive radical 2 over 2. Can anyone tell me where that might be?
7 pi over 4.
7 pi over 4 down in quadrant 4. And you guys, when you look at your unit circle, those two places will have for cosine dx. The radical 2 over 2. I can't accept both. We're talking about a 1-to-1 function here. Maybe I have to rule out something. Pi over 4, let me check the guys first. That radical 2 over 2, if you approximate, does fit this domain down here. I'm good there. Down here, the answer must fall between 0 and 180 by restriction. Does 45 degrees fall between 0 and 180? This one is like 315. Would 315 fall between 0 and 180 by restriction? No, so this has to be marked out. So your final answer is merely one answer, which we expect, 5/4. Okay. Number 2, inverse cosine, negative radical 2/2. Can someone give me a response that you think will fit the conditions? And by the way, this number inside here, I will tell you, does fit the domain. Now, know between 0 and pi, does anyone have an idea? Negative 5/4. It will work. Number 3. Let's see, what else do I need here? Hang on. Michael, hang on. Back up here, pi/4, 45 degrees, definitely falls here. What you just gave me, oh, good. Negative 5/4, there are no negative angles in this one. Right? Over here, I could accept the negative because there's a negative involved in the restriction of the sign. Cosine has no negatives. So I'm just gonna leave that. So we're gonna come to another one. So where on the unit circle have you seen the x, the cosine, equal to a negative radical 2/2?
3 pi over 4.
Out here, 3 pi/4. Roberto, 3 pi/4. Guy, can you tell the class, was there another one just out of curiosity? Where the
5
x
pi over 4.
5 pi/4. Now it's 135 degrees. Would that fall between 0 and 180? This one he gave me, which is on the unit circle, is 225. Would 225 fall here? No. So when he gave me 3 pi/4 is the answer. Look at this. Where inverse cosine is 3 pi/4. Wow. And I could continue with this. Let me throw in one more, it's not curiosity. Number 3, I've got 3 right. Inverse cosine, and don't you dare miss this one. -1. And by the way, I can use a -1 for my domain. So where have you seen the x coordinate equal to a -1? Pi. Now let me jot down first. Michael says pi. Guys, would pi be accepted based on this condition? Thank goodness they placed a bracket there. I can use it. Is that true? And that's the way the inverses work. One more. Inverse tan is the last one I'm gonna have you guys be responsible for. If you leave, you go to math 7, all of a sudden that math 7 class, the instructor says inverse cosecant. It's there. It's just that we did not do it here. I think most of us stick with the basics here. Okay, A, B, C, let's go with C. Last one, I'd like to consider this one. Then we'll get back to the question that was brought up earlier. Guys, inverse tan. Let's first consider the basic graph for tan. And I'm trying to recall, please tell me, I think if you look back in your notes, we, in this class, accepted, do watch out, correct me, that the parent tan graph looks something like this. Yes or no? Squeeze that in. Did we see that earlier somewhere in your notes? Okay, so that's about parent graph. Brianna, if I accept this as my parent graph, like I accepted my sine graph, I had to wipe some off. I accepted my parent cosine graph, I had to wipe some graph off. Look at this one. This one's 1-to-1. I read it just like it is. I don't have to erase something. It's 1-to-1 right now. So if it is 1 to 1, we'll just jump right into it. The domain on this graph is open, negative pi over 2, up to a positive pi over 2. Range on this one, oh, look at the range. Negative infinity through positive infinity. Therefore, if I have a discussion on its inverse, the domain of the inverse, like this, should be the same as the range of the previous, and the range of the inverse should be the same as the domain of the original. Nice. Gotta know these restrictions. Now, on the side here's just a few examples. So if you're asked to find tan, inverse tan. Now, inside there, my domain, my domain is open. Oh, this is open, I can place any number I wish in there. 100, 10, 5, 3 point, whatever, any number. Let me try a number that you guys would recognize from the unit circle. Let's try 1. Keep in mind, guys, that inside there, domain can be anything here. Now, can anyone recall where on the unit circle, if you place y over x, you get 1?
Pi over 4.
Do again.
Pi over 4.
5 and 4, very good. I know, I think, guys, tell me, is there a spot somewhere else also besides 5 and 4? Is it 5, 5 and 4? It is. You place y over x, you get a 1. I can't accept both. You know that, because it's 1 to 1. That's why they give you this restriction out here. You can only accept the one that'll fall between negative 90 and a positive 90. And I think it's 45 degrees would fall between negative 90 and positive 90. This is 225. That would not fit. So the answer is, guys, 5 or 4. And the last one, inverse tan, 0. Where have you seen to place y over x, it gave you a value of, on that unit circle, 0.
0.
Okay, let's try it. Now, let's see if it works now. If it is 0, right here, you know this is 0, 0, right? And you're doing y over x. Or on the unit circle, you're thinking Michael. You're thinking Professor. I'm thinking about this on the unit circle right here. Was that 1, 0 on the unit circle? And if I place y over x, I'm placing 0 over 1, will that work then? And does 0 fit between these two? Guys, that's the problem. Mr. Park, get ready for it. Close this down. I give you an idea what inverses are all about. Before I ask Park to do something for me, can anyone tell me in this class, and I told you I've been bragging on it, could anyone tell me real quickly, what do you think the graph of the inverse of tan looks like? Where things are being interchanged. You'll be shocked. I should have done it on the others also. What do you think the, not the piece wiped off, not this is a regular function. What is the graph of the inverse? What it looks like? Let's try it on this one. Yeah.
Can you reflect it over y equals x?
Beautiful, you could. Beautiful, beautiful, beautiful. Tell me something else. You could. Anyone have an idea? We're shocked at what this is all about. I think I'm so glad I thought about this before I close down. I like to graph inverse tan on this tan graph. Let's stay right. Roberto.
Is it coating?
No? Oh, I see why you're saying that. Oh, whoa, 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 whoa. We're not saying that. That superscript -1 does not mean 1 over. It means inverse.
But is the graph of cotan equal to
Whoa,
the
whoa,
inverse
whoa.
of tan?
I see what you're thinking, mathematician over there. No, I don't want that. Something else. Okay, here we go, so I won't waste too much more time, I just wanna leave this. Is there a vertical asymptote right here at negative pi over two?
It's horizontal.
It becomes a horizontal. If you want to graph of the inverse. So that means you should have a horizontal down here at what? Negative pi over two. Here goes, guys. And was there another vertical asymptote at pi over two? And things are being switched. This should now turn from a vertical into a what? A horizontal. So it's up here at pi over two. And looks like, I'm gonna step back and look at it and see if you guys may see what's gonna happen. Might, oh boy, here goes, might the graph of the inverse to follow those horizontal asymptotes look something like this. Yes or no? In the green there. To follow the horizontal asymptotes? Brianna, I love what you said. That was a mathematician there. She says, Professor, I think I remember when we first did these, there was something about y is equal to x. And when you guys did a composite, you're supposed to get x. Guess what? If you graph y is equal to x, let me do it in a different color here. What colors do I have? Blue here. Guys, this is y is equal to x, a nice straight line through the origin. That's your reflecting line. For those two pieces. Make sense? Can you guys see that? So I'll throw that in. Goodbye to inverses. I usually do more with them, but we don't have the time. Just give you the basics. Now, I had a question. I think I had a question earlier before I leave all this. What was that question? Oh, yeah, on the handout. Here we go. On the handout, he's concerned about, read that to me.
Question is tan, 10 degrees,
Okay, hang on.
cotangent,
And 10 degree times, wasn't it?
cotangent of 170 degrees
There you go.
minus cosine of 180.
Okay, and we're mostly concerned about that first part. That was on the handout. Okay. Now, if I do a little thinking, he's already done the thinking for me. I wish other instructors could hear you guys. 170, that's not an angle we usually work with. But I know it is out there. I know where it is. 170 degrees terminates in quadrant 2. It's not on the unit circle, I don't know much about it myself. It's there, right? Yeah, right below it, it's called the reference angle. It's this little angle. We have 10 degrees left over there. So I should be able to express, that's why he was saying so beautifully, that's why I was doing my work over there. Is there some way to express cotangent? Cotangent 170. Can I call that, and I'm in quadrant 2, I gotta be careful. And quadrant 2, guys, has for coordinates what? Negative, positive? I'm doing cotangent, x over y, so it's gonna be a negative answer. Negative answer for the cotangent. So it's gonna be negative here. Can I call that negative cotangent of 10 degrees? Should they be equivalent? Sounds like we're doing it with the inverses. Just renaming. And if that's true, he was telling me I should let him tell the class. He said, wait, Professor, cotangent is the same as the reciprocal of tan. Why can't I write that as this? You can. And then on the side here, you still have this. That true? And then finally, so why did part have an answer of -1? I think it was, at least for that part. These will cancel out. And all this was -1 for that part. Beautiful. Absolutely beautiful. that finish up and get the full answer, that, one on the end, cosine 180, that's directly on the unit circle. That's a -1. So I think you end up with, for a final answer, -1, what, +1? 0. Mathematics. Mathematics. Okay, that's all I'm gonna do with inverses. I wish I could do more, that's all I'm gonna do. Michael, what's the next part say I'm supposed to be doing? Showing parts of what next? Is it solving equations? It says solve equations. Okay, guys, we step back. Look at this. Looks overwhelming. The pieces do start coming together. Okay, guys, I need to erase this. We're supposed to take a break about 10 minutes. And that quiz is so short. I got a little bit more time after the break than usual to do what I gotta do. Okay, Michael, I may not be able to do all of them. I'm doing maybe one or two of those solid and see if we can get it work out for us. Mr. Parker, are they gonna give you a diagnostic of some sort when you get to Berkeley? Do they give those diagnostic tests? Have they mentioned anything like that?
I'm not sure,
Oh,
but
yeah, yeah, when you meet your class, you'll see what they're looking at.
yeah.
Yeah, guys, when you move into math 7, they're gonna give you a diagnostic here. Some of the instructors give one that's in the book they use. That's a diagnostic test. I'm gonna get a copy of that and just give it to you. Finish this class up. Okay, part 3, here we go. Michael, tell me please, what's the first one that they're asking me now to solve?
Cosine theta equals 1/2.
Oh my goodness. And did they tell me where to look for it?
No.
Oh, no, this goes out beautifully. Okay, guys, this comes down to where have you seen the x coordinate equal to a 1/2 on that beautiful unit circle? Yeah, cosine is 1/2. 5/3. And is there another one? Positive 1/2, cosine. Where is cosine positive besides quadrant 1 that he's already given me? Quadrant what, 4? So what angle down in quadrant 4 has an x coordinate cosine of 1/2? Is it 5 pi over 3? Is it true, guys? Yes, no? So those are two. Now, does anyone see an inverse notation up here? Does anyone see a superscript negative sign here? No, so I can accept both these. In fact, I can accept this. Theta is equal to, Michael, look at this. Someone said, oh, this is open this time. I don't see any inverse notations restricted like this over there. Pi over 3 plus the period for cosine is 2 pi. You may do this. I'm going to put n, where n is an element of the integers, and say, if it's here, it works. And on the last one there, 5 pi over 3, which works. If you make a complete revolution and go back to it again, it's going to work again. So and write that as to show all of them with that period number for cosine 2 pi. N is an element of the integers. There's your answer. Okay, and you could start replacing n by 0, n by 1, n by 2 in both of these, and come up with other possibilities. I'll just leave mine like that. Michael, what was the next one?
Cosine 2 theta equals 1/2.
Okay, here we go.
This one.
Right.
0 is less than or equal to.
Oh, the restriction here, 0 is less than or equal to
Theta
theta.
less than 2 pi.
The restriction on this one. Okay. Okay, 0 and 2 pi. Now the guys who say, well, they put a 2 in there. If you want to graph this, that would be a horizontal shrink by a factor of 1/2. I don't want to graph it. But you guys, what we're going to do here, first you're going to take note of where have you seen this to begin with equal to a 1/2. X coordinate equal to a 1/2. on the unit circle, where have you seen at least that much? Pi over three, so that means this right here must be representing, look at this, pi over three. And by the way, since they want maybe all the answers, and I'll put restrictions here, but Michael says there's a restriction on this, but I'm gonna write like this, guys. The period number for cosine to make that repeat is two pi n, where n is an element of the integers. So I'm gonna write like that. Then we'll come back to it. Can anyone tell me besides pi over three, is there another spot on that unit circle where the x-coordinate cosine is 1/2 besides pi over three? Who has an idea? Besides pi over three is a positive 1/2, so you're in quadrant one, or down in quadrant four again. Is it the same as 5 pi over three? This is 5 pi over three, plus that period number to make things repeat. Think of this period for cosine is 2 pi. And we have, at this point, that. Let's go back, we want theta, not 2 theta, so solve, divide by 2. And get this, makes this theta is equal to, I'll do it fairly quickly, pi over 6 plus pi n. I mean, we are getting a little sophisticated in this math. That's theta when I solve it. I solve for theta over here in the second possibility, divide by 2. It's 5 pi over 6, we'll multiply by 1/2. We get this. N is an element of the integers. You know, stop, guys, we'll take a break here shortly. Okay. Now, let's go back to each one. This one, I'm gonna start replacing n by 0, n by 1, n by 2, and do as much as I can here and come up with some answers for this blue up here. So you guys on this one, watch carefully. I'm gonna start with 0. You can use any integer you wish. I'm gonna start with 0. If I replace n by 0, that term drops out, leaves me pi over 6 for a possibility for theta. And Michael says, as long as I stay between 0 and 360, you use it. Okay, therefore I can use 30 degrees. Okay, let's try 1. Let's see if I can get another one. I'll replace n by 1 here. You end up with pi over 6 plus pi. Common denominator of 6. I'm trying to do it in my head here, guys. What is that, 7 pi over 6? So that would be 7 pi over 6, which is 210 degrees, I think. Would that fit here? So we're okay so far. I've seen some of these bring this quite a few. We'll try one more. When n is 2. In this one. If I put a 2 in, guys, I get pi over 6 plus 2 pi. Common denominator 6. I'm gonna get 13 pi over 6, I think. I think that's outside what we want. He says you can just go up to 2 pi. So I think 13 pi over 6 is over. If that works, can't use it. That's done. Now he said, Professor, what else? You gotta go down and do it on this one. Let n be 0 on this one. You get another possibility. If you let n be 0, that term drops out, leaves you 5 pi over 6. Does. Done. If you let n be 1, you end up with 5 pi over 6 plus pi, common denominator 6. I think it's 11 pi over 6, if you guys agree. Which I think is okay. It'll fit between 0 and 2 pi. If you try 2, guys, you will go outside what he gave you. Do we agree? We have 4 answers up here. Where was it? Oh, right here. Place it right here, guys. I don't care what order you put these in. Let me try to find my answers here first. I got 5 over 6, 7 pi over 6, 5 pi over 6, 11 pi over 6. Let me close that up. And those are my answers. Wow. I see some looks like, what? What? They're do a 10-minute break, then you guys will be back here shortly. Just going to do a 10-minute break now. Come back.